Yes, senior three students, all level learners, whether in senior 4, senior 3 or senior 2, we welcome you to this learning platform, BAC Science Education Consultants, where we tackle subjects like physics, math, biology and chemistry. You can find us on our YouTube channel, BAC Science Education Consultants. And BAC Science Education Consultants is our YouTube channel. Reach us anytime and in whatever situation. I am Naija Pison, a teacher of physics and mathematics. But today I'm gonna take you through mathematics of O level. Last time we discussed in our lesson 2 of matrices, we talked about operation of matrices, and this mainly covered addition, multiplication, and subtraction. We can have a small recap of what we talked about. Say that if we have a matrix A given by 2, 1, 4, 5, and then a matrix B given by 4, 3, 0, 1, then we can do operation. That is addition of A and B, whereby we said we simply substitute as the normal addition. And then, while adding matrices, we said we add corresponding elements. The first element with the first, second with the second, and then the orders of rows and columns must follow. So we shall be having A plus B equaling 2 plus 4, and then 1 plus 0, and then 4 plus 3, and then 5 plus 0. And then you enclose them in brackets, and then that makes a matrix. This is a 6, a 1. Therefore, A plus B is equal to that. You repeat the procedures for subtraction. You subtract corresponding elements in the matrices. The condition we said, the matrices, for them to be added and subtraction, they must be having the same order. That is equal number of rows and columns. We multiplied these matrices whereby we said if we want to multiply matrix A and B, then we simply substitute and say it is 2, 1, 4, 5 multiplied with 4, 3, 0, 1. And in the process of multiplying, we said we multiply rows by columns. While we are multiplying rows by columns, you multiply the corresponding component, that is 2 times 4, and you add 1 times 3. Then you also say row by column, 2 times 0, and then you add 1 times 1, 1 times 1. Then you also go to another row by column, 4 times 4, then you add 5 times 3. Then you also go to another column, 4 times 0, and then you add 5 times 1. That is a process of multiplication of matrices, and this simply gives us 8 plus 3, which is 11, 0 plus 0 plus 5, which is a 5. So, multiplication of A and B simply gives that matrix. Today, we shall advance to another aspect of matrices, which we shall call identity matrix. Identity matrix. Identity matrix definition. We also call it identity matrix I. We abbreviate it by capital I. And identity matrix is a matrix whose all other elements except in the major diagonal are zeros and the rest are ones. So, we need to identify these two things. If I give you a matrix A, and I say it is given by A, B, C, D, what are the elements in the major diagonal? This is the first diagonal, this is the second diagonal. This is called a major diagonal, and another one is called the minor diagonal, opposite of major. So the matrix specifically has two diagonals, a major and a For an identity matrix, elements in the major diagonal must all be ones, and all the other elements must be zeros. For example, a 2 by 2 identity matrix. We say the 2 by 2, it must be having 2 rows and 2 columns. Therefore, the first element, of course, we say the first element must be a 1, and the last element here must be a 1. Here a 0, here a 0. Because we want to have the leading diagonal being 1s and all other elements being zeros. A 3 by 3 identity matrix is written as 1 0 0 0 1 0 and 0 0 1. We want to see all the elements in the leading diagonal or the major diagonal being equal to 1 and all other elements being zeros, and that is what we call an identity matrix. The other condition for identity matrix, we say that all identity matrices must be square matrices. What do they mean? All matrices must be having equal number of rows and columns. If it has 2 rows, it must be having 2 columns. If it has 3 rows, it must be having 3 columns. 4 columns and 4 rows, 5 rows and 5 columns, and so on and so on. Because it isn't possible to have a leading diagonal in a non-square matrix. It isn't possible to have a minor diagonal in a non-square matrix. So it must be a square matrix. Identify a leading diagonal, put only ones, and the rest of the elements has to be zeros. How do we apply this in calculations? Example number 1. A is equal to 1, 1, x, y. Find x and y. They are saying we are given a matrix A, which is given by 1, 1, x, y. We don't know the values of x and y, but they are saying when we square a matrix A, then the answer must be an identity matrix. Wherever you see this I, know it is identity matrix. Find the values of x and y. If that is true, they are saying a squared should be equal to I. And we know that a squared is same as a times a, which should be equal to identity matrix. And we know, of course, what identity matrix is. So if we multiply 1, 1, xy with 1, 1, xy, then we must get an identity matrix of order 2 by 2, which is 1, 0, 0, 1. And let's see in multiplication, row by column. 1 times 1 is 1. We add there 1 times x is x. Then we cross row by column. 1 times 1 is 1. We add there 1 times y is y. Then we got another row by column. X times 1 is x plus y times x is yx. Then we got another column. Row by column. X times 1 is x, y is y squared. So we have this equal to 1. And if two matrices are equal, then their corresponding elements should be equal. The first element in the first matrix is 1 plus x. Here it is 1. And therefore it implies that 1 plus x should be equal to 1. And if that is true, by taking this one this side, we have x only here equaling to 1. When it goes this side, it becomes a negative, and this gives you 0. Therefore, x is equal to 0 is its value. Then you got another element. The second element here is 1 plus y, and here it is a 0. It simply means that 1 plus y is equal to 0, and crossing this one this side, it leaves you with y here. It it finds a 0 and it becomes negative 1, and this implies that 1 is equal to negative 1. So the corresponding values of x and y are 0 and negative 1 respectively. That is the application of identity matrices. Question number 2. It is saying, given that two matrices A and B, you are given the values of A and B, find a matrix M such that 3M minus 2I equals 2A minus B. Simply substitute. I represents an identity matrix. Substitute its value, substitute the value of A and substitute the value of B. Make M the subject, and remember M is a matrix, and get its value. You comment with your answer, or whatever a problem may be, you can tell me on my YouTube channel, BAC Science Education Consultants. There is also an email, naijapison@gmail.com, reach to me, also the phone numbers. Please subscribe, share with your friends so they can also learn. Thank you very much. May God bless you.